everybody, this is section 8.1 and we're looking at confidence intervals for a population mean. So in this section, you're trying to estimate a population mean and you don't know what it is. And this is a very common situation, and as you go through journals you will find lots of confidence intervals and times when people were saying, well, we didn't know something so we tried to estimate it. The confidence interval for body mass index was blank. So it's important to know how to use a confidence interval. This example, page 384, and it's question number 59, looking at Wii game sales. This question makes me laugh a little bit because the problem's only about 2 years old, but already gaming platforms have changed so much that Wii isn't really a big contender anymore. Interestingly, Nintendo is still in the game because they own all the rights to their beloved characters, namely Super Mario and Pokemon and Legend of Zelda, always a classic, not to mention Animal Crossing, a personal favorite. Anyway, so in this problem, they are trying to estimate the mean number of games sold on a Wii platform back in this day. All right, so here's the sample. It says, assume the number of units sold ending da-da-da, here it is. So here's the data. They have 8 different games, and these were the thousands of units that were sold for each of these different games. And they're saying, assume that sigma equals 30,000. So here's a tricky thing. Do you see how the units here, it's 65, that means 65,000, like that. Oops, add a 0. And this one's 30,000. So in your mind, you want to think of it as 30,000, like that. That way all the numbers are consistent as you're going through the problem. Anyway, so here is the raw data. Let's look at the question. Part A says, do a normal probability plot. Easy, we're not going to do it. So don't do the normal probability plot. It's really challenging to do if you don't have the right technology, so we're just going to skip that part. And go to question part B. Assuming that game sales are normally distributed, construct and interpret a 99% confidence interval for the population mean number of games sold. So I want to call your attention to a couple things. One, assuming the games are normally distributed. That's important. So great, they're normally distributed. That means we can use our formulas for this section. And then it says, construct and interpret a 99% confidence interval for the population mean number of games sold. That's also important. Mean number of games sold. Let's go to our little paint picture. Okay, let's cancel that. So, over here, the first thing I do with these confidence intervals is I write what we're looking for. In this case, mu, that's a mu, equals the population mean number of Wii games sold. They're trying to estimate the mean number of games sold, and I'll say per week. Sometimes you get involved in these problems and you forget what you're looking for, so I find it helpful for each problem to write down what this population parameter is that you're estimating. So this is what we want to know. We don't know what it is, and we're trying to estimate it. So we're going to use a confidence interval. Because we know that the population is normal, because they told us it was normally distributed, we can use this formula. X bar plus or minus Z critical, sometimes they call that Z alpha over 2, times sigma over the square root of n. Your book calls that Z alpha over 2. Okay? So let's go back and look at our data and fill in the gaps here. Here's our data. So we know sigma, that's the standard deviation, equals 30,000. N equals 1, 2, 3, 4, 5, 6, 7, 8. Back here. So far we know sigma equals 30. You'll notice that it's 30,000, but we're going to leave it as 30. N is equal to 8. The Z critical, it's for 99%. So you go to your table. I'm trying to find all of these pieces for the formula. Here's the Z critical table. So 99% is right there. 2.576 equals 2.576. So we have this piece, Z critical, sigma, and all we need is this, X bar. So how are we going to find X bar? Well, it's not that challenging. We have all this data, and basically you just want the sample mean of these 8 numbers. So you're going to add them all up and divide by n. Okay. So again, to find this x bar, you're going to add up all the numbers and divide by n. In this case, when you do that, you get, what did I get my x bar to be? 54.875. Where does 54.875 come from? That's 65 plus 40 plus 74 plus 16 plus 56 plus 36 plus 42 plus 110, all of that. And then you sort of divide by 8, right? So you'd add up all of these and divide them by 8. If you forgot, I'll say sum slash divide by 8. If you forgot how to do this, let me go to the bottom here. You can find x bar on your calculator. This is a bit tedious, but remember you can go to stat, and then you can go to the edit function, and then you can arrow over to calc. Excuse me, after you hit edit, you have to enter all the data into list 1. Remember how we did this? This is chapter 3, a nice review for the final. So you enter all the data, and then you go over to calc, and you hit one variable statistics, hit enter, and then when it's waiting for you, you hit L1, that's second function 1, and then it'll give you x bar equals that same number. But in this case, it might actually be easier just to add them all up and divide by 8. X bar equals 54.875. Note, the calculator gives you this standard deviation and sample standard deviation, but remember, this is because the calculator's just looking at this little sample right here. It's looking at this sample and saying, well, the standard deviation of this sample is, where was it? 28.692, or if we considered that sample a population, it would be this standard deviation. So you're basically going to ignore these numbers and use what the book tells you as the estimate of the population standard deviation. So back to the problem. Here's our formula right here, and now we have all the pieces. So we can write 54.875, that's x bar, plus or minus z critical 2.576 times sigma, which is 30,000. I'm just going to leave it at 30 because all of the numbers were also in thousands, so we're keeping it consistent. Divided by 8, so that's 54.875 plus or minus all of that. When you multiply it together, gets to be 27.322. Okay, so we have 54.875 plus or minus 27.322. This gives us 27.553, comma, that's the lower bound, 82.187. So here's the confidence interval. It's kind of big, actually, I think. So it's 27.553 to 82.187. That's the confidence interval. A 99% confidence interval for mu, which is the mean number of games sold per week. Do you see how that's helpful? Because by the time we put all these numbers, we've forgotten what we're doing. I've forgotten what we're doing. So here it is. To find the confidence interval on the calculator, this is how you would do it. You would go to stat and then hit enter, and then you go over to tests, and then you go over to 7, which is z interval, 7z interval, and then for input you want to hit data or stats. So I'd probably use stats because I think it's a little bit easier. For sigma you type in 30, for x bar you type in 54 point, what was that, 875, n is 8, confidence level 0.99, and then you just hit calculate, and it'll essentially do the same thing we did right there. It'll just do this plus or minus bit. And when you do that, you get, the calculator gives you 27.554, comma 82.196. Okay. So you could also choose to do data, but then you'd have to refer it to list 1, so it's a little bit complicated, but it's also doable. And we're not quite done with the problem. The question says interpret the confidence interval. So here is your sentence, your interpretation sentence. Write this on your card. We are 99% confident that the true mean population number of games, this part, true mean population number of games, remember, that's what we're looking for, the mean number of games sold is between, you type it in, 27.875 and 82.196. You can use either one of these. It doesn't really matter. I don't care about the rounding. With 99% confidence. Again. Excuse me. We don't need that part. There. We are 99% confident that the true mean population number of games sold per week is between 27.875 and 92.196. If you use this sentence, you will always have a correct interpretation. So it's a good thing to write down or have memorized. This part A took a while, so we'll do part B and C in another video. Look for that.